think I've had enough. Might get a little drunk. I think I've had enough. Might get a little drunk. I think I've had enough.
Good morning, everyone. Good morning. Hope all is well. Hope everybody's doing all right. Let's see. Looks like everybody's in. Hope you had a great weekend. Did anybody have any questions or anything before we get rolling? Everybody good? All right. Let's see. All right. So we did 3-6 last class. Looking at 3-7 today. Modeling using variation. And that's our last section out of chapter 3. Let's see. Let me think about it, Mr. Bailey. Let me think about it. All right. All right, so 3.7 modeling using variation. The first one that we're going to come across is direct variation. So basically what's going to happen in these problems, you'll see a phrase, a key phrase that's going to dictate how you set up your problem. Here's is varies directly or directly proportional to. And so Y is what comes in front of that, and X is what comes after that. And the way we'll set it up is this way. Y equal to K times X, where K is your constant of variation. So if you see, once again, varies directly or directly proportional to, then this is how you're going to set up your problem. All right. Scroll up. All right, first problem, the distance that a body falls from rest varies directly as the square of the time of the fall. If the skydivers fall 64 feet in 2 seconds, how far will they fall in 4.5 seconds? All right. So we'll do it in steps, and hopefully if you hold true to the steps, then that'll set you up to be able to do all the rest of the problems because all the problems in this section flow with the same type of format. They're going to give you this key phrase. What's in front of the key phrase is going to be your Y. What's after the key phrase will be your X. Then they'll give you enough, all of the information for one relationship. Then they'll be missing one piece, and you'll be able to find that piece according to the relationship and everything like that. All right. So first thing you want to do is identify the variation setup. It varies directly. All right. So that means you're going to be using Y equal to K times X. Next, you want to establish your variables. It doesn't matter what you call, these variables as long as you don't use K. So if you have something that says, let's say you have a problem that deals with kinetic energy, you wouldn't want to use K for kinetic. You maybe use E for energy, but K is your constant of variation. Remember, that's always going to be a part of your setup. And all of these problems, K will always be a part of the setup. So you don't want to use K as your variables. So notice we have what's in front of varies is your Y. And that was, let me go here, the distance that a ball falls from rest. So I call that D for distance. And then what comes after your phrase is that X, and it's the square of the time of the fall. So I call it T for time. Once again, you can call these whatever you want to call them, but you don't want to call it K because we already have our K, our constant of variation. Any problems with steps 1 and 2? All right. Then we're going to write the equation. So like I said, what goes in front of your phrasing is where the Y goes, and then what comes after the phrasing is where X goes. So that's why we have D equal to KT squared, and it's T squared because it says the square of the time. All right. Questions? Any questions? All right. So the given information, once again, they will give you all of one relationship, and then you'll be missing a piece of the second relationship. So go back. Skydivers fall 64 feet in 2 seconds. So that's all of one relationship. Then in the next relationship, how far would they fall in 4.5 seconds? So in the first relationship, distance is 64. Seconds is 2. Second relationship, 4.5 is your seconds, and we don't know the distance. And that's what we're trying to figure out. All right. All right, so we'll use the equation in the first set of information, talking about this right here, to figure out what K is. So your K is your constant of variation. That's going to be the constant throughout this variation problem. So D is equal to K times T squared. We can go ahead and plug in D1 and D2, D1 and T1, that first set of information. So 64 for D, 2 for T. I should put that right there. So you're going to substitute in D1 and T1 into the equation and solve for K. Any problems? Any problems? Now we're going to substitute K into the equation. Now we have the equation D is equal to 16T squared. And now for step 7, we can use the second set of information and the new equation to find the missing piece. Remember, all we had was 4.5, and we want to know what distance is traveled in 4.5 seconds. So we can plug 4.5 in for T. All right, 4.5 squared is 20.25. 16 times 20.25 is 324. So that would be the answer. All right, questions? Any questions? All right, can you do the next one? All right, next one is varying inversely, or let's say inverse variation. So it's the same format, it's just that this keyword sets us up to have K over X instead of K times X. So direct variation does the multiplication, K times X. Inverse variation does K over X. As always, if I scroll up too fast, let me know. Let me get on. Nah, okay. So,
You can back up. I didn't finish writing inverse variation. I thank you.
mhm.
Okay, you can go back down now.
Thank you. All right, so when you use a spray can and press the valve at the top, you decrease the pressure of the gas in the can. In general, if the temperature is constant, the pressure of a gas in a container varies inversely as the volume of the container. So I'll give you a chance to write that part before you scroll all the way up, or before you scroll up some more, I should say. All right, scrolling up some. So the pressure of a gas sample in a container whose volume is 8 cubic inches and 12 pounds per square inch. If the sample expands to a volume of 22 cubic inches, I don't know how far it can go up. Pause right here. So we're looking for the new pressure of the gas. Right. Okay, so key phrase here is going to be inversely. And that means we're going to set it up this way, y equal to k over x. Remember, y is going to be whatever's in front of your phrasing varies inversely. And then x is going to be what comes after it. Now, if you go up to what comes before varies inversely, you have the pressure of the gas, and then what comes after, the volume of the container. So that's why I have P equal to pressure, V is equal to volume. All right. Plug in your variables. That'll be P equal to K over V. All right, so just like before, you have all the information of one relationship, then you're missing a piece of another. So the pressure is 12, volume is 8 for the first relationship. For the second one, we don't know what your pressure is, but it gives the volume of 22 cubic, what was it, cubic inches. Any problems? So now we want to figure out what K is, and we'll use the first set of information in order to do that. Plug in 12 for P, 8 for V. Solve for K, multiplying both sides by 8, and that'll be 96. K is equal to 96. And that's our new formula. P is equal to 96 over V. Any problems? Any problems? All right, so now we're going to plug in the one piece that we have from the new relationship and find the missing piece. So we know what V is. We don't know what P is, so you plug in V. It's 22. And of course, MATLAB will let you know where, what way they want the answer, whether they want it in fractional form or decimal. Any questions? Any problems? Any problems? All right, so combined variation is when more than one variation is used. And so just mentioning that because that's going to flow into the next problem. And then if you see the word joint variation, that means you're going to set it up this way. So we're going to do both of those in the next problem. Joint variation. And, just in case the terminology is used, in MATLAB or something, combined variation is when you use more than one variation. So you'll see how that flows into the next one. But if it says varies jointly, that's K times X times Z. So you have another variable that you'll be multiplying to the K. All right. All right, then scroll up. Good. All right. So the centrifugal force of a body moving in a circle varies jointly with the radius of the circular path and the body's mass, and inversely with the square of the time. It takes with the square of the time it takes to move a boat one full circle. I will say rotation, but circle. All right. With the square of the time it takes to move a boat. I said a boat about one full circle. A 6 gram body moving in a circle with radius 100 centimeters. Trying to write something that's a little better. At the rate of 1 revolution. I'll pause right here, give you guys a chance to write. All right, gonna scroll up. So we have a 6 gram body moving in a circle with radius 100 centimeters at a rate of 1 revolution in 2 seconds has a centrifugal force of 600 dynes. That's DYNES. Find the centrifugal force of an 18-gram body moving in a circle with radius of 100 centimeters. All right, can we scroll up? So if we look at starting the problem off, they give us 2 key phrases here. That's why it's combined. Variation says that it varies inversely and jointly. So jointly, kxz inversely would be k over x. And we're going to combine those in a second. Like I said, just give you guys a chance to finish writing it down. All right. So what came before our varies was the centrifugal force, and it was jointly with the radius and the mass. You see it right here. And then inversely with the square of the time. So I have these four letters right here. Centrifugal force for C, R for radius, M for mass, T for time. So you're always looking at what comes before your varies and what comes directly after that phrasing to help you set up your variables. All right, so took both of those, brought them together, we do it like this. And this is what we have. C came before your varies, that's your centrifugal force. It varies jointly with the radius and the mass, and then inversely with the square of time. So that's why the t squared is on bottom. K, once again, is just your constant of variation. Any problems, any problems? All right, so once again, write down the given information. They give us all of one set of information. Then they give you everything except for one piece in the second information. That will always be the case with the problems that you get. You'll have all of one information or all of one relationship, then you'll be missing one piece of the second relationship. Any problems, any problems? All right. So plug in the first set of information, 6,000 for C, 100 for R, 6 for M, 2 for T. So 100 times 6 divided by 2 squared simplifies to 150. Divide both sides by 150, K is equal to 40. Any problems? Any problems? No, plug in 40 for K. Any problems? Any problems? Okay, now the seventh step. We don't know what the centrifugal force is, but they gave us all the other pieces. So we go ahead and plug that in. R for 100, M for 18, 3 for T. And then when you simplify all of that, that will be 8,000 dynes. Any questions? Any questions? Very good, everybody straight. Questions on the process, questions on anything that we did. So going back, is anybody still copying? Very good. All right. So just making sure we okay with what's going on. So you always identify your variation, find that key phrasing, whether it's inverse, jointly, directly, whatever phrase they're using, figure out what they're using, and then set up your problem accordingly. That'll let you know what formula you're going to be using. Establish your variables. Then go ahead and put those variables into the equation. From there, all of your problems in this section will give you all of the first relationship, then be missing one piece of the second relationship. So that will always be the flow of every problem in this section. So you're going to use that first set of information, plug it in, and then solve for K. Once you find K, remember K is your constant of variation. That's the same for all of the whole for the rest of the problem. Once you find out K, that's going to stay the same. So plug in K and you have your full formula now. Then you'll be able to use the second set of information to figure out the missing piece. All right. And that's the same for all of them. All right, so questions on anything before I move off this? Good, straight. All right, so that is it for chapter 3. Let me look at something real quick. Okay, so we need to start prepping for this test. So next class will be a review day. You guys will be able to bring whatever questions you have to class, and I will address them.
Can we do a review Kahoot?
What was that? A review Kahoot?
Uh-huh.
What does that mean?
Do you know what a Kahoot is?
No.
You don't know what Kahoot is?
It's
Now,
like a game.
oh, you talking about that game? Okay, yeah, I remember
Yeah, the
playing
like
it.
4 colors that you like pick from our phones and we all can like log on.
Okay, let's see, let's see. I think, well, I've done, which one did I use? Is it similar to, what's the name of that app that I used before? Oh, I can't think of the name, but I had little rocket ships and you could answer the question and it would go up. But Kahoot, I think I played it once. Well, what's the foundation? Do I get to make up problems and put it in Apple? What is
I think
what is your
I
thought
think they
process behind it?
sometimes have like platforms of like already made questions.
Mhm,
And then there's also like an option to like make your own version with your own questions. And
mhm.
then yeah, you just put in like the question and answers, and then you give us all a game code to log on through our phones. And then we all can just like pick the answers off our phones if you share your screen with us on Zoom.
Right. I'm looking at it now. I'm not texting. I'm actually looking while you're talking, saying what you think I was just like, yeah, whatever. Let me see. Let's see. Yeah, you are a teacher. All right. So Kahoot. I wonder, do I have an account with this already? Because I know I played something like this before in the past. So I will look into it. So for the person who suggested that, did you have something in mind or you just throwing something out there as far as how we would use it?
Well, you said like we were gonna have our review day, and I figured instead of just being like, does anybody have any questions, maybe you could like throw questions like either from the textbook or if like off the test review, and just be like, here, like we can answer these questions and kind of go over certain topics together again.
Mm-hmm. Gotcha. So yeah, I should be able to do that. I'll play around with it and see if I can make it happen by Wednesday. So I don't mind trying stuff out, see if
Thank
it can
you.
work. Yeah, no problem. Uh, 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 Probably better if I do it up here. Anything else? Anybody else? So we'll try to do that and try to see if I can make it so that it can be like, if I can, I gotta, like I said, I gotta go in and play with it. If I can figure out a way to see, record whose answers went where and all the stuff like that, may be able to assign some extra credit to it or something like that. So we'll see. All right.
I
So
don't necessarily know if it tells you who answered what, but like I know at the end it tells you who came in like first, second, and third.
gotcha. So yeah. So that's what so I'll try to do it like that and see if there's a way. Like I said, even if it was the first, second, or third, that would be good enough, you know what I mean, to be able to uh, assign some extra credit points for participating. All right. So anything else? Anybody else? All right. So next class, we are reviewing. So if we do this Kahoot game, then what I'll probably do is, like she mentioned, pull problems from the actual test review. And then I'll let you guys take a shot. And then if you have questions on them, try to review those problems like that. Do something along those lines. So we'll see how that works and go from there. All right. So anything else? Anybody else before we close today? That's all we got. Like I said, that's the end of chapter 3. Anybody have any questions right now? Or are we good to go until we roll into next class? So what I may do as well, is do the game on Wednesday and then let's try going through the game. And then on Monday, do, does anybody have any questions, or I might do them flipped. Maybe if I can't get the game generated by Wednesday, like the way I want it, then we'll do just like hey, questions, and then do the game one day. Well, anyway, I'll figure it out though. I think it's a good idea. When is chapter 3 due? So,
Mr. Tucker, did you assign dates to homework and tests? I didn't quite hear that if you did.
not for chapter 3 yet. Not if
Okay.
that, yeah. So that's what one of your classmates just hit me in the chat about. So today is the 25th. 7/14. Let's see what's going on in math lab real quick. What you guys are up to. Just give me a little time. All right, so the 14th next week. Of this week, the next week is the 7th, 14th. So I give you 31st, 7th, 14th. So that'd be 3 Sundays. So November 14th. I think it should be good, a good date. Yeah, I'm thinking that should be a good date. It's 3 Sundays from now. From this Sunday coming up be 31st, then you have the 7th, and then you have the 14th. So and as with all things, if you come across a situation and you need an extension, then it's nothing but an email conversation. That's all. All right. Anything else? Anybody else? All right. So you guys have a good one. Be safe. And I will see you on next class.
Have a good day.
Thanks. You do the same. Take care.
See you later.
Take care. Thanks.
Bye. Thank you, Mr. Tucker.
All right. Thank you. Have a good one.